Okay, so the first thing is to take a quick look at the picture. So there's a few labeled angles and different things that we can see here. So if we set up the picture, it looks something like this. We know that this is 15 degrees. We know that this angle here is 25 degrees. Okay, and we know that this length right here is 1,000. Okay, so if we know this is 25 degrees, we also know this angle right here. So we would take 180 minus 25. So that would give me an angle here of 155. Okay, that also means that we know this angle here, okay, which means we know the opposite angle from the 1,000 feet. So we can go ahead and calculate that. So we would do 180 minus the 155, which would give me 25. That 25 minus the 15 means that we're talking about an angle here of 10 degrees. Okay, so once you have a corresponding side angle pair, then you know that you are set up to use the law of sines. So you know that you'd have the sine of 10 degrees divided by 1,000. Okay, and then that would be equal to another ratio of a corresponding side angle pair. So they're asking, they've labeled this as Q and this point as P. So they're asking in the problem for the distance between P and Q. And so that would relate to this 15 degree angle. So you'd be looking at the sine of 15 degrees over that side. And you can call it whatever you want. So we can go ahead and call it B. Once you have that proportion, then you should be able to go ahead and cross multiply. So B times the sine of 10 degrees should be equal to 1,000 times the sine of 15 degrees. We should be able to divide by the sine of 10 degrees and divide by the sine of 10 degrees. So B should be equal to 1,000 times the sine of 15 degrees divided by the sine of 10 degrees. Okay, so we're using the law of sines here. And then we can plug that into a calculator and see what we end up with. And you should get, let me check in the back here. We should get approximately 1,490.48 feet. So you could double check that calculation in your calculator and see if that's correct.